this segment we will consider components of a vector. Okay, consider a vector A. Vector A, this figure, you draw A such that its tail is at the cartesian, is at the origin of the cartesian plane, just like this, just like this. The components of this vector are its projection along the x and y axis. Okay, the x component is denoted as ax, and the y component is denoted as ay. So the component ax and ay are positive if they point towards the positive x direction, and positive y direction respectively. Okay. Okay. The components ax, okay, and ay are called scalar components. They are called scalar components. That is, the a along the x direction and that along the y direction are both called scalar components. Okay. The resultant vector, okay, which is denoted as this, is the sum of the components. The sum of the components. That is vector A, which is the resultant vector. You can call that one AR. In this case, resultant vector will be the summation of vector A x, this component along the x axis and the component along what the y axis. We can resolve the vectors. That's if we know the magnitude and direction of the vector. If we know the magnitude and the direction of the vector, we can determine its components using trigonometric ratio. Okay, so this is known as resolving vector. It's into its components. Okay, in this figure, if the magnitude of A, you can see the magnitude of A is known, and the direction is theta. From the positive x-axis direction, this is positive x-axis, and then of course positive y. So the x and y components of vector A can then be given as ax be equals to a cos theta. Right. And along y direction, you have ay to be equals to ay will be a sine theta. Ax will be equals to a cos theta, and ay, that is the components of a, vector A, along y direction will be a sine theta. So it will always be given this way. That is, ax will be equals to a cos theta and ay will be equals to a sine theta, provided that the angle theta is between the vector. Okay, provided that the angle theta is between the vector, okay, and the axis. All right. So conversely, you can have a which is vector A to be equals to square root of A x squared plus AY squared. Now, in this case, the components are known, and the magnitude of the vector and direction can be computed. See, that is the magnitude of A. See, alright? So the what can be given as this, provided that the magnitude or the components are known and the magnitude of the vector and direction computed. Okay, in this case, the direction is given by theta. So when you give the inverse of that, you remember your SOHCAHTOA. Tan theta, if you come to this place, you see tan theta will be equals to what? Opposite. Okay? Over what? Over adjacent. So in this case, you have AY over what? Over AX. Okay? So invariably, your theta becomes tan arc. You take the inverse of the tan theta. Okay? Don't forget AY over what? AX. Right. Addition of vector using components. And I'm going to follow this using 4 steps. Step 1, what you should do, you draw the vectors. Draw the vectors. Don't forget, this is a vector on its own. Okay? This is a vector on its own. Okay? You draw these vectors such that their tails are at the origin. Okay? Don't forget, their tails must be at the origin. Okay? Alright, and that's what gives you this. Okay? Vector A forms an angle at 30 degrees here with the positive x-axis. Vector B, on the other side, forms an angle of 40 degrees with the negative x-axis. This is the negative, don't forget, this is your negative x-axis, negative x-axis, okay, here. And of course, this is negative what? Y-axis. This is what? Positive x-axis, which I've shown previously, and this one, of course, is positive y-axis. These are very, very important while resolving our vector. Okay, so you should draw that. Don't forget that all the tails must be at the origin. Okay, so now we can find the resultant R. Okay, the resultant R of these vectors. That is the R, which usually be given as this, denoted as R. A plus vector B plus, of course, vector C. Okay. So that's the first step to it. Okay. The second step is you should draw the components. Draw the components of vectors and indicate their direction. Once you are done drawing the vectors such that their tails are the origin, then you should indicate their direction. Okay, this is the same one repeated here, but in this case we are now indicating the directions. Okay, you can see the direction that this one is going. This one is going in what direction? This one is going this direction. This is going that direction. All right. Can see. All right. So the direction of bx. This is b. This is vector b with this side. Okay. This side is vector b side, and this side is vector a side, and of course the downward side, okay, down like this is vector c. Okay. Okay, so we don't want to get this complicated. We don't want to get it complicated. So, but you must understand that along this is bx, okay? Along this direction is ax, because this is a side, okay? And along this side is what? Is a c, that's a cy, okay? So, the third thing to do, once you have been able to indicate their directions in this manner, then you should compute the x component. You can compute the x component of all the vectors and add them. You repeat the same for the y components in this manner. Okay? That is, for the a side, for the x component, you have ax and ay. For the b component, or the for the vector b, you have x, bx component and by component. Invariably, what you can have the x component resolved. That is, you have ax and bx. You can also have ax and b. You can have bx and ax. That is for the x component. You can have ay and by, and that is for the y components. Okay. Or you follow it through this way. Ax will be equals to a cos that. In this case, should we use this diagram? Okay. In this case, you have ax component will be equals to a cos 30 degree. You can see that. And then for ay, you can see it will be a sine 30 degree. Okay. All right. So vector a in this case, vector a, that is the resultant vector in this case, okay, will be equals to ax plus what? Plus what? Plus ay. Right. So you can also resolve the b, vector b, in this manner. You can also say bx plus by. Okay? Now, the c side of it, do not forget, however, that the bx is negative. You know why? So you can have b be equals to bx plus that is minus bx plus what? Plus by. Do you understand that? You know why? Because the bx is at the negative x axis. Okay. All right. So, but in the case of c, you see the cy is at the negative of what? Of of the um the y-axis. Okay, so that's why in this case you have minus c sine theta, but in this case it's 0, so theta is 0 in this case. All right. Okay, so theta is 0, so that will be sine 0 degree, so that gives you minus c. Okay, so for the cx you have plus c cos 90 degree, because that will be at 90. Don't forget. Okay, and what is that? That'll be 0. Cos 90 degree gives you 0. Okay, 0 multiplied by c gives you 0. That's how you come arrive at this. Okay, so for the resultant vector along the x direction, okay, it will be equals to ax. You can add all the x components now in this manner to make it very straightforward. Ax plus, do not forget, minus bx, and I repeat, you have minus bx because it is at the negative x-axis. Okay? Okay. So minus bx plus cx. So you have been able to select the like of uh, the vectors or the components along the x direction. Okay? And you can do similar, you repeat the same for the y direction. Okay, so in this case you have ay plus by plus what? Minus cy. It is minus because the cy is at the negative y axis. Okay, so the fourth thing to do, the first step to take once you are able to do that, first you should be able. So the fourth thing to do, okay, in addition of vector using component is that you can compute the magnitude of the resultant vector R in this manner. So this is what you have for the resultant vector. So okay, you have resolved, you have selected all these x terms. Okay, you have selected all these x terms, you have selected for the y. So what you need to do, you now have the resultant of the x and y. Okay, recall that your Rx like this, you have taken the ax plus what? Minus bx plus what? Cx. Okay? And then your y to be equals to what? Your ay plus what? By. In this case, now you have plus minus cx. You know why? Because it's at the negative, y axis. Okay? cy. So, okay, let's not mix it up. So, in the direction of the resultant vector. That's the fifth thing to do. Okay. For this segment, I'm going to give you an example. You show me your answers in the comment section. So before we'll quickly resolve that in the next in our next class. Okay. So quickly, let me show you these examples. We can look at this example together. I want you to resolve that in the comment section. I'm going to be going through the comment section to see your answers. Find the resultant of the three vectors in the drawing below. Look at this drawing. Okay, you can take this one like this. So it's 240-degree inclined. You can see vector A, okay, up north. You can see vector B, all right, along the positive x-axis. This is A is along the positive what or axis, and then you have of course your C. All right, so I want you to add on these vectors, assuming you now have. Please take note of this. Um, the vectors A and B are perpendicular to each other. You can see they are perpendicular to each other, and the magnitude of A, B, and C are given as 10. Okay, the magnitude are given as 10 for A. You see, you have this 10. Okay, and for B is given to be 20, and of course C is given to be 15. You understand that respectively those are 15 units. That's for C. So in this case I want you to find the resultant of the three vectors. Okay, you follow the same procedure. All right, so let me see what you can do. Go through the comment section and let's see. So number 2, you can also find the resultant of the two vectors. In this case you have three vectors. For here you have just A and B, vector A and vector B. You understand? So maybe we should do like this, for uniformity. Okay, so You can find the resultant of the two vectors in this drawing. Okay, let's say the vector A makes an angle of 25 degree. You can see that here, 25 degree with the positive x-axis, and vector B makes what, an angle of 40 degree with the negative x-axis. Okay, so in this case, let's say the magnitude, the magnitude, the magnitudes, the magnitudes of magnitudes of A and B are, let's say, 50 meter and 30 meters units respectively. Okay. Okay, so yes, you can take this A to be equals to 30. You can take that. Let me show you more clearly. So yes, 30 for that's for B, right? So 50 for A, 50 meter units, and this one for B will be 30 meter units respectively. You can show me your answer. Maybe I can just give you a clue to what it could be. All right. Okay. So R for this, the resultant vector, so it should be 22.4 meter. Okay, hope you get that. Do you get that? So for the theta, you have to get the direction. It should be equals to 4.6 degree. Can you just go through this, and let me see what you get during the conversation. I'm Dr. Olakunle Ogujobi.